In this video, we will show how to implement Poisson distribution in Python. So first, we will talk a little bit about Poisson distribution. Poisson distribution is used to model the discrete count event occurrence in a specific period. This can be a time period or the area, specific area, for example. And the number x of outcomes occurring during a Poisson experiment is called a Poisson random variable. And its probability distribution is called the Poisson distribution. So the mean number of outcomes is computed from mu equals lambda t. So the t is specific time, distance, area, or volume of interest. And the lambda is called the rate of occurrence of outcomes in a unit time period, a unit distance, unit area. And the calculation of the probability for specific occurrence of number x in this time period, for example, 3 hours, so can be calculated as the division of two parts. The denominator is this number's factorial. So for example, if we want to find out the probability of occurring 2 times in 10 hours, so here we have to fill in 2 factorial in denominator. And in the numerator part, the 2 parts multiplication. The first is power. The power part is negative lambda t. So lambda t is also this mu. For example, we know average 1 point of time occurrence in 1 hour. So 10 hour lambda t will be 15 here. So the next part is also 15th. Power is 2 here. So this formula is called the probability of Poisson random number with px lambda t. So usually we often use mu here, just a mu. So mu represents the average occurrence in the long run, the average occurrence in this time period, not necessarily the unit time period. It's any time period in this for this mu. So the Poisson distributions mean and variance are equal. They are both equal to mu equals lambda t. So we only has one parameter is enough to define a Poisson distribution, and this parameter is mu. So the average numbers occurrence in the long run or lambda t for this time period. So in Python, mainly we use 3 functions to work with Poisson distribution. The first is poisson.rvs. It uses to generate random number, and this random number is discrete, maybe 1, 2, 3, 4, and so on. Depends on the mean average occurrence in this period, right? And second function is poisson.pmf. This is a probability function used to calculate the probability of this random number or occurrence time in this time period. And the third is CDF, cumulative distribution function. So this is used to calculate the cumulative probability up to this discrete number. So for example, we want to know the probability of occurring 0, 1, 2, 3, 4. 1, 2, 3, 4 is the total probability of these 4 occurrence during a specific time period. So next we will show some examples to perform Poisson distribution in Python. So first we have to import module, import points module from package scipy.stats. So scipy is statistic package. If we have to check if it is not available, so we have to install scipy. But usually this is bundled with Python installation. If you use Python in, for example, framework of Anaconda. So next we generate random number from points distribution with mean 8 here, and we sample 20 random number. So we'll see how it is going. So the 20 random number will be returned as an array, and the array, and you can see 4, 7, 5, 8, they're all discrete number around the mean 8. So next is used to calculate the probability related to the specific count value from Poisson distribution. So we also load Poisson module, then we calculate the probability of occurring. So this example is, for example, a store sells 8 ice creams per day on average. So what is the probability that they will sell 10 apples on 10 ice creams? So what is the probability that they will sell 10 ice creams on a given day? So this question is, we want to know the probability associated with a particular count number. So here this count number is 10. And we know the average or the mu or the lambda t is 8 here in this time period. So we just use poisson.pmf, k equals 10 and mu equals 8. So very easy. This is about 0.1. Only 10% you can get exactly. This is exactly 10 occurrence in this given day. So next function is Poisson CDF. We will apply. The example is to calculate the probability that's less than some value, this discrete value. The example is a call center has an average of 5 calls coming in per hour. And what is the probability that this call center has 4 or less incoming call during a given hour? So here, the given hour is the unit time. Also, this is a specific time we want to focus on. So this 5 is the mu, also lambda, because 1 hour, so 5 times 1 is also 5. So we can specify this 5 as the mu of this given hour, right? And what we want to know is the probability, cumulative probability of occurring 0, 1, 2, 3, 4 in this given hour. So load the module. Then we calculate poisson.cdf, here's cumulative distribution function, with k equals 4, mu equals 5. About 0.44. So about 44% of the time we'll have incoming call less than or equal to 4. And the third example is to calculate probability which is greater than some value for the counting value. Where occurrence is greater than some value. So certain store sells 15 cans of tuna per day on average. And what is the probability that this store sells more than 20 cans of tuna in a given day? So here we want to know the probability of Poisson distribution with this count number, which is larger than a certain value. So we can calculate the cumulative probability of less than or equal to this certain value. Then use 1 minus this cumulative probability. Right? So we just fill in k is 20 and mu equals 15. So that's about 0.0829 of the probability that this store will sell more than 20 cans in a given day. So quite infrequent occurrence of this event, right? It's a very low probability to sell more than 20 if average is 15 in a Poisson distribution. So in summary, we can use 3 functions in Poisson distribution in Python. So RV is for the random number generation, and a PMF for the probability function for a specific count number, and a CDF is a cumulative distribution. No matter we want to calculate less than some value or larger than some value. So thanks for watching.